Hello students, welcome to RD Chemistry. In this video, I'll discuss the concept of radius of orbits. We have hydrogen atom with atomic number Z is equal to 1. Its electronic configuration is a 1s1. So we have got a nucleus, and around the nucleus there is only one shell containing that electron. Okay, so there's only one orbit of shell, that the radius of the shell number 1 is actually equal to exact value 0.529 angstrom units, which can be generally converted into picometers, or you can convert it into meters or nanometers. Okay, we can calculate radius of any shell, radius of second shell in the hydrogen atom, even though there is no electrons, or we can find out the radius of any shell in the another atom. You remember the formula, radius of any shell is equal to, it is connected to radius of the hydrogen atom, radius of the first shell of the hydrogen atom into n square divided by z. Thus radius of the first orbit of the hydrogen atom is equal to, in terms of angstrom, 0.529 angstrom units. Okay, so we can also write radius of the nth shell is equal to, since it's a constant, generally it is also written as the r naught into n square divided by z, where this r1 of hydrogen is also equal to r naught. Okay, so I can fix it like this. Radius of the nth shell is equal to 0.529 n square divided by z in terms of angstrom units. Okay, fine. Now remember this note. Circumference of nth orbit is equal to n times the wavelength of the electron. Circumference 2 pi r is equal to n times the wavelength of the electron. This r stands for radius of the nth shell. Okay, so 2 pi r is equal to n lambda. We'll have to remember. Fine. Read this question. Which state of triply ionized beryllium B plus 3 has the same orbit radius as that of the ground state of the hydrogen atom? Ground state of the hydrogen atom is equal to n is equal to 1. Shell number is equal to 1. First shell. Okay. Hydrogen, helium, lithium, beryllium. Beryllium atomic number is equal to 4. Okay. That means there are 4 electrons are there. Beryllium plus 3 means it is left with the only 1 electron. Okay. So it is a hydrogen-like species. Now we have the formula. Radius of initial is equal to radius of the first shell of the hydrogen atom into n square divided by z. Right? Question is same as the orbit radius of the ground state of the hydrogen atom. That means both the radius should be same. So I'll take 0.529 angstrom units is equal to 0.529 angstrom units into n square divided by z. N square we don't know, which state we don't know, divided by z. For beryllium, z is equal to 4. Right? So these are the common terms. So therefore n square is equal to 4, n is equal to 2. So they are speak about the beryllium 3 plus second shell have the same radius as that of the first shell of the radius of the hydrogen atom. Okay. Next question. Ionization energy of hydrogen-like atom. Hydrogen-like atom is 4 Rydberg, and Rydberg values in terms of joules. Remember, what is the radius of the first orbit of this atom? To find out the radius of any shell, we require actually 2 data. One is the n value, other one is the z value. N value is already given first shell. We'll have to find out that value from the first data, ionization energy. Remember student, ionization energy of any atom like a hydrogen like atom is equal to ionization energy of the hydrogen atom itself, correct, into z square divided by n square. Hope you remember one of the previous videos I had explained. Okay, and they're telling that ionization energy of the hydrogen like atom is equal to 4 Rydberg, 4 into RL, right, 4 Rydberg. So we'll connect only this, these two parts. Ionization energy I want in terms of joule because Rydberg is in terms of joule. Remember, I told you there are many values in terms of electron volt per atom, joule per atom, kilojoule per atom. So we'll be writing only joules, but they're given for atom, we'll write for atom, single atom. So you remember like 2.18 I written into 10 power minus 18 into z square I write down. And you know that n is 1 they are given, which is equal to 4 into R value is equal to 2.2 into 10 power minus 18. These two terms are almost same values, very close to 1. So z square is equal to 4, therefore z is equal to 2. So atomic number is equal to 2. When atomic number is 2, it is should be helium, right? Now we'll proceed to calculate the radius of the shell. Now we have z is equal to 2, then we calculate radius of the initial. Radius initial is equal to radius of the first shell into, we know that n square divided by z, correct? So we want the radius of the first shell, dimension first orbit, is equal to fixed number 0.529 angstrom into n square is 1 divided by z value already found out 2, in terms of angstrom units, correct? So this is equal to 0.264, right, into angstrom is 10 power minus 10 in terms of meters. Or finally I can write in terms of scientific notation, it should be 2.64 into 10 power minus 11 meters. Fine. See the third question. Determine the de Broglie wavelength associated with an electron in the third Bohr's orbit of the helium plus. Helium atomic number Z is equal to 2. When the helium, there are altogether 2 electrons. When I say helium plus 1, it will be left with the only 1 electron. So it is a hydrogen like atom. Okay, fine. Now wavelength and the orbit they are given. Remember I had given the formula 2 pi r is equal to n lambda, where r is the radius of the third shell. Okay, even though helium has got only 1 electron, that electron need not be in the first shell, it can be second shell, third shell, maybe in the excited state. Okay, right? And this n is equal to 3 itself, so we can find out the de Broglie wavelength lambda. But we want to know what the radius of third shell. Radius of third shell is equal to radius of the first shell into, you know that this is the n square divided by z, which is equal to 0.529, you know that in terms of angstrom units, into third shell, n is equal to 3, so 9, and atomic number z is equal to 2, right? So lambda is equal to 2 pi radius of the third shell divided by n. So 2 into 3.14 divided by n is equal to 3 into radius third shell 0.529 into 9 by 2 into angstrom units it is, correct? So it is a 3 ones are and 3 threes are, and this 2 and 2 get cancelled, and this is approximately comes to be 5 angstrom units. Okay, fine. Now I will write down the radius the first, second, third, fourth of the hydrogen atom. You know that radius initial is equal to radius of the first atom into n square divided by z. I want to write down the radius of second, third, fourth in terms of r1 only. When n shell number is equal to 1, radius is r1. When shell number n is equal to 2, n is equal to R2 at find out. R2 is equal to R1 into radius second shell becomes 4, doubling it. And speak of the hydrogen atom, for hydrogen atom Z is equal to 1. Correct? Or you remember R is radius initial is directly proportional to N square. I'm keeping the same atom. Okay? So therefore, first radius R1, second radius you have to double the shell number for R1 times. Correct? For the third one, 3 square, 9. This is like 1 square. This is a 2 square, 3 square, 4 square, 16. So R1 and R1. 5 square, 25, R1 goes like this. Okay? Fine? Yeah, this problem can be as simple problems can be asked. If you like this video, please do like, share and subscribe. Thank you for watching. Have a nice day.